All right, we're going to be learning about the periodic table of elements and its importance in chemistry. So first of all, what is the table all about? Well, the periodic table of elements is a structure in the form of a table that is every known element broken up by its electron counts, by its proton counts, by its atomic mass. It contains data about all of those, and it also, and some tables will showcase whether the category is a metal, a metalloid, or a non-metal. Those are all very important when it comes to chemistry because we know based upon how those chemical components will react and how those elements and atoms will behave, all because of what has been organized into what we call the periodic table. So the table is broken up into two major sections. There's going to be the columns, which is what goes up and down. These are also known as the groups or the families. The reason that they are called families is because everything in the family or the column up and down behaves in the exact same way. The reason for this, as noticed on the last slide, is because of the valence electrons. These are the electrons that are in the outermost level of the atom or the element. And because of that, if it has the same number of valence electrons, it's going to behave very much in the same way, much like a family or a group will behave in very much the same way. So when you get to rows, however, rows are what go right to left. Rows will stack on top of each other, and those are called periods. So all the periods combine together into these various rows, and they are based upon which valence shell of the electron is being full. So is there 1 up to 8 in that outer shell. Now, depending on how many are in there, it's going to behave differently, like I said, with the families and the columns, but we know which shell is being taken based upon the period that the electrons fill or in the element that they take. So what is in an element? Well, each of these little squares on the periodic table is an element. So each element has several different pieces of information. The main ones that you usually want to focus on are the name, the mass, and the atomic number. Almost every single periodic table has this. Several other ones have increased information such as electronegativity and other components such as the structural 3D shaping of it. Those are a little more advanced chemistry. We're just going to stick to the very basics right now. So first of all, mass. The atomic mass is the average of all the element of this name that are in the observed universe. So how do we know what, an element is within an observed name? Well, the name is given in the actual column is going to say the name and then a 2-letter abbreviation. Because the mass varies, it's not a perfect even number. The reason is there's not an 18th or a 5th of a component floating around in there. It's because there are some that are heavier and there are some that are going to be lighter. We'll get to this in the next slide. Now, the atomic number is the number of protons that the element contains. In the case on the screen, we have neon, which has a perfect 10. If you look at that, that means that it's going to have the first valence level of 2 full and then the second valence level of 8 full, combining to make 10. So neon is not going to want to combine with pretty much anything, and if it does combine, it's going to take a lot of energy to make it combine. We're going to get to that in a couple slides as well. So the mass is the atomic mass number. It's usually the larger number. This is the combination of the protons and the neutrons in the core of the element or in the core of the atom. The atomic number is simply the number of protons. Okay? So pluses and minuses. Plus is going to be a proton. This is a positively charged part of the atom or part of the element that resides in the center of the molecule or of the atom or the element. It also resides with the neutrons, which are listed at the bottom, neutral charged particles. The minus in the equation is the electrons. Now, because everything has to be balanced, the base element of whatever you choose is going to have the same number of protons as it does electrons. The reason is that the charges have to be balanced. When they're not balanced, that's when you get into what we're going to be talking about next. So the neutrons, as I mentioned earlier, some such as in carbon. Carbon is a 6 proton, 6 electron setup, and it's going to, 12, so 12 overall, and it is going to have various combinations where it's going to have a 14 level where it's going to have 8 of the neutrons. That's very highly radioactive. It's going to have the base level, which is going to have 6, which is very stable, and it's going to have some that have 7. The base number of the atomic mass for carbon is 12.01, which means 99.9% of it is carbon-12, stable carbon. However, there are some radioactive carbons, higher level neutrons, that have this extra energy that's going to be 13 and 14. All right, so what happens when these atoms bond? So when atoms and elements combine, they become compounds. So these compounds can take different kind of combinations. So an ionic compound is going to be a metal and a non-metal. Typically, it's going to be something from the very ends, and they're going to overlap. The reason being is there's an electron transfer. If one of the components, such as chlorine, has 7, and it needs 8 to make a full ring, and another has 1, such as sodium, that's going to have 1 extra on its valence electron base. Those two get together, they transfer, and then they bond, and they combine that ring together. They make a stable compound then, known as NaCl, which is table salt. Covalent, on the other hand, is a non-metal and a non-metal. So what that happens is that's going to be like 2 oxygen, or oxygen and nitrogen, or carbon and oxygen mixing together, because they're both non-metal. So they share those electrons. Sometimes they go around one and sometimes they go around the other. So these can be both polar or non-polar. Getting a little more advanced here, but what happens is when you create something that's polar or non-polar, what it does is it creates a positive or a negative charge because the electrons are pulled more one way versus the other. There is completely non-polar, which is going to be no charge whatsoever, and then there's polar, where there's a charge one side and a charge the other side. Then there are metallic bonds. These are when the electrons just kind of float around together. Some chemical compounds, such as iron, can have a +2 or a +3 charge because they're just in a sea of electrons. It's like sometimes it works with 2, sometimes it works with 3, but it's usually when the metals are bonded, or either together or with other elements of metallic structure. So, in summary, the thing that you need to know about the periodic table is location, location, location. When it comes to elements, location tells you everything you need to know about how that particular element is going to behave individually, not in more in-depth compounds, because that's what the rest of chemistry is about. When you take something like the periodic table and you combine it with a molar conversion table, you have 90+% of the tools that you need for most of chemistry in order to figure out what works and how it works together. So, hope you enjoyed. Thank you very much.